A Python function is a block of usable code that performs a specific task. It allows you to encapsulate a piece of code, give it a name, and then call it from other parts of your program. Defining your function. To define a function, you use the def keyword followed by the name of the function. And in this case, we want to write a very simple function that just greet and has no input. And then you end your function. And the next thing you do here is we just want to print something very simple, and we say hello world. We just finished writing our function that does what? That prints hello world to the console. But now it's pretty useless without you calling it. If you try to run this function, nothing gets executed. For you to be able to make use of this function, you have to call it within the body of your program. Before you can use a function, it has to be declared first before the calling of your program. So how do you call your function? You just repeat the function name followed by the bracket. So if you run this, you have your result, hello world. So this is a basic function declaration with no input. Function parameters. Function parameters are variables that are passed into the function. They allow you to provide input data to the function. Functions can have multiple parameters separated by commas, and they can have different value or data type. So let's run another example. In this case, we want to add two numbers. So we define the function using the keyword def, and we say add. So what are the things we want to add? We want to add the input that has been provided by the user. So in this case, we'll have A and B. So we'll go ahead and say print A plus B. So if we call this function now by doing so, now if you call this function, remember the way we call the first function, we call it just by specifying greet without anything inside it. And this is because there was no parameter required. In this case, this example requires us to pass a parameter. We need to pass parameter for A and B. And since it's to add, we can just add numbers. And if you run this, you have a result. You have a 6 there. Good. The next part we want to go to is explaining return statements. Functions can return data using the return statement. These statements terminate the function and return a value or multiple values to the caller. Okay, let's see. Another function we want to write now is, I will modify this first function to use the return keyword. So I will say return A plus B. In this case, when you run this program, the value of A plus B is returned to the caller. Hence, it will not print to the console. It will return and stay inside here. You are not assigning to anything. So a way to test this out is to assign it to a value. And say value is equal to whatever you run with A, add 4 and 2, return it to value. Then you can print your result like this and say value. So if you run this, we still get the same result as executed below. So we can change this input to give us something different. So here we now have 9. This is an example using the return keyword. And whenever the code gets to return, it will terminate your program. So this is an example to show you how return works. So if you run this program now, your program will never print this result. What your program will print is that it will print none, because at this execution, the program gets to line 7, it will just stop and return none. So that's what happens. So return always stop the execution of your function. Function argument determine the data type the argument of a function has. In this case of this example of adding, we were able to define that this function accepts 2 inputs, but we didn't tell what kind of data type that it should hold. You can see that when using it, it's saying that we can actually supply any data type. But you and I know that if you supply a value that is not a number, the system is going to give you an error. So this will result into an error. And how do you make sure that the system catches this kind of error? Is to enforce a data type while creating your function. To enforce the data type, you go to the declaration of the parameter and you specify a column followed by the data type that you want. So in this case, we'll be accepting a float, and also our B value can also accept a float. So when you run this, in creation of this, you will then see that the function is specifying and telling you, the user, that it requires float for its operation. So you can then determine what you want to pass in here, and you can then have a better result. Now you can specify default value for a parameter. Let's go to our first definition that we have here, which is to greet, a greet function. And in this case, I want to pass two parameters. And the first one should be your name, the name of the person you want to greet. And you can say, yeah, this one should be a string. Then the next one should be the greeting, like what it is you want to tell the person. To make a parameter have a default value, you put the name of the variable equal to the value that you want it to have by default. So here we can say the default value should be hello, so that in my result, I can then say print, say the greeting, followed by the name of the person. So we'll always have something like this. So if I say greet this person, I can say James. Then if I try to run this, we'll have hello James. So meaning every time you say greet, it will use the keyword hello. So, but what if you want to change the pattern in which you greet? You want to change it from hello and say hi, for example. So it means you have to pass the second parameter, which is then going to be greeting. And the second parameter is going to be hi. So if you run this, it's going to say hi, James. So you have a function that allows you to be able to set a default parameter. And this is how you can set that, by setting that the parameter is equal to a value while creating the function. And you can see the definition of the function here in the output. Recursion is a programming technique where a function calls itself in order to solve a problem. It is a powerful concept commonly used in solving problems that can be broken down into smaller, similar sub-problems. In a recursive solution, the problem is solved by dividing it into smaller instances of the same problem until the base case is reached. Remember the keyword base case. There must be a base case. If there's no base case, it will run forever. So let's create a function to count 1 to 10 using recursive. So we have our def, and then you say count. That's the function name you want to have there. And then of course, you have to pass a parameter. What do you want to count? I have my number, and then I want it to be an integer. The next thing you want to do is to end this, and you want it to be able to print our result, which is the n. And while printing your result, you also want to be able to call it n. So what this does is that it calls itself continuously. So I do return n. So our return terminates the process, and then it goes over and over and over again. The problem with this is that you've not created a base case. What does a base case mean? A base case is the termination of your function. At what point will your function ever terminate? So you need to put that case there. So it's at the case where our n becomes 0. Whenever our n becomes 0, terminate the recursion. So we can say if n is equal to 0, terminate. How do you remember how to terminate, guys? Use return. So this will terminate your function whenever it gets to 0. Then if you run this, it will never terminate because your n doesn't have a way to kind of reduce. So you need to be able to reduce your n continuously so that it will always reach 0. And the way to do that is to pass a reduced value of n into your function. And what happens in this case is that your n will always be reduced whenever you run it. Let's give it a try and say print count. So count from 10. And when you run this, you have this result. It starts from 0, 9, 8, 7, like that, till it gets to the last item. It returns 0 instead here. Then when you run this, you have it properly done like so. Another thing I want to show you now is how we can implement the power of default parameter in this case. Because you can decide to say, okay, you want your recursive to end at a certain point. This is all saying you want the recursive to end at 0. What if you want it to end as a certain number? So you can pass in another parameter here in your declaration of your function, and in this case, we'll make it by default, it should end at 0. So your condition should also match that, so that this will be end at 0. And what you are returning, once it meets that end, return what your end is. So if you run this, it will always end at 5, and you can change that to suit whatever you need. So if you say 6, it will end at 6. So you could say run this to 100 and stop at maybe 95. So this is where it will count down and stop at 95. You could say stop at 5, and you can run all this, it will stop at 5. That is the power of recursive function. You can actually determine what your function return. So let's define a function, say def, and you say you want to add two numbers, a plus b. And your first number, you want it to be a float, and your second number, you want it to be an int, just for the fun of it. Then you can say your return variable of these two things should become an int, and you terminate it this way. So the new thing we've added here now is our arrow function, or dash and arrow, to indicate that you can only return an integer after all these things, or after the body, whatever you would have done in the computation of the body, you could only return an int. So if you try to return something else, it will not work. So let's go ahead and do return. So you are forcing an integer return. So this is a control to make sure that whatever it is that the system is trying to do, you always have a kind of data type that is returned from that function. So you can have your a exponential b, for example. So this can be a great example to say exponential. So this can be creating an exponential function, meaning you can have a float here and you raise it to the power of an integer. Then maybe you want to return an integer for some reason, then you have this result. So let's have a test of this. 4.4 raised to the power of 2. Let's see what we have, and it gives us 19. Obviously, we know the real value is not 19. If you want to have that with the float information, you can say, oh, you want to return a float, which should be the ideal thing. Automatically, this will result into a float, so you won't have problem in resolving that issue. So you have this, the exact value of 4.4 raised to the power of 2. So if you say 16, just for the check of it, if you say 4, we should have 16. 89, you have this. So by the time you have a decimal, obviously you will have something in this fashion. Default value is very important. You can be using it a lot. Since this is an exponential, most of the time when we deal with exponential, it's always by 2. So you could always do something like this, and this will be the assumption that your value that you are raising to the power of is always 2. So, but you want to do it in such a way that the system is dynamic to accept something even different. So you can have raised to the power of 4 or raised to the power of 11. I need to do the math for you, but you can always make use of the functionality of the default value. So let's talk about variable scope. If you have a variable declared here, and look at the indentation, guys, is not defined in any code block, so it's starting from the beginning. So I'll call this G for global, and you have a function, and within that function, you can actually make use of your global variable. You can make use of your global variable within that function. So let's run this, guys, and see how it goes. So you can do your func1, and you can call it. So if I run this now, I can call, I'm in a function, global. I'm in a function global. So let's also make use of it directly by just printing it as a program. So this is you calling the variable normally because you've declared it. So variable declared outside of a function can be used within that function. But it's not a general practice. Always try to make sure that functions are self-sufficient, that they can use whatever they've created. But in some cases, you might want to make use of a global variable declared like this. But the reverse is not the case. What does that mean? A variable you declare here is local to that function. So you can always do something like this. I'm in a function I can call local. However, you cannot call a variable declared in a function like so. You can see that it's giving you an underline error. L is not defined, meaning all the things you've done in your function is hidden from your program. But the function have access to what is happening outside the program. So if you run this now, you can see that the local variable is being executed. The global variable, you can see it. The local variable is accessible inside the function, but it's not accessible outside the function.